In this demonstration, I'm going to do the very famous Pringles can. Hydrogen explosion. Any case, what I have here is a Pringle can, upside down, with a hole drilled on top. I have some flexible tape here, flex tape just for supportive reasons. And I have a hole drilled, and I also have a hole at the bottom part of the can here where the top lid comes off. And I got the lid on, and what I'm going to do is I'm going to flush this can with hydrogen. So to do so, I've got my hydrogen generator here, which is made of zinc metal, who has 2 valence electrons that loves to give its electrons to H+ ions. H+ ions are going to come from my hydrochloric acid. Acids give off protons or H+, and H+ are like heat-sinking missiles for electrons. They're small, their charge density is high, and they're +1, and they basically pull electrons away from this metal here. And if hydrogen pluses grab electrons, they become hydrogen atoms. And hydrogen atoms use each other to bond covalently to become hydrogen gas molecules. And of course, hydrogen is flammable. Okay, it reacts with oxygen, but only with the right ratio of oxygen. So if you've balanced your reaction in class with H2 and O2, you'll see there's 2 hydrogen molecules for every 1 oxygen molecules. Any case, that's the reaction we're looking for. What's nice about this reaction, it'll only occur when we approximate that ratio. So I'm basically attaching the tube into my can here, and I'm going to flush this with hydrogen. So I'm going to pour hydrochloric acid into my Erlenmeyer flask, and we're going to first flush out any oxygen that would be in my container. Okay, so a lot of this is hydrogen leaving. We have some water because it is an aqueous solution. It's a very exothermic reaction, so we're actually generating water vapor, probably some hydrochloric vapors a little bit too. Okay, in any case, that looks pretty flushed out. I'm going to give it a little more H+ ions, and now I'm going to connect the stopper, which is now connected to my Pringles can. And the Pringles can, of course, has the hydrogen coming at the top. Okay, so the same thing is I'm going to flush this out, all of this Pringles can, all the volume of air in here, all the oxygen I'm taking out, all the oxygen and all the air out. So I have 100%, or at least approximate 100% hydrogen. If you look carefully, I'm not sure if you can see this from the camera, but you see some of the same condensation occurring here that's coming through. And I'm going to wait a little bit, make sure I flush this out, because if I try to light this right now, it'll explode. Okay, there's probably enough oxygen with the right 2-to-1 ratio to make this explode. But if I fill this up with it entirely filled with hydrogen, okay, there will not be enough oxygen to react with the hydrogen. And if I light this once it's filled, I'll just have a flame exposed where it's reacting. All I have to do is wait. When I light the top and pull this out, air will be drawn through the bottom opening as I burn off the hydrogen. And as air rushes in, when I approximate that 2-to-1 ratio, when enough oxygen enters the Pringles can, then and only then will I have an explosion inside the can and have what I call good cake, or a balanced reaction. So this reaction, the explosion, will only occur when I have the approximate 2-to-1 ratio that we get by balancing. So let's do this. I've flushed this out. Okay, take this tube away. Let's light this. And it's hard to see the flame from there, but once that flame disappears, okay, we're drawing enough oxygen to get that right 2-to-1 ratio of hydrogen to oxygen. Here it comes. We get our nice reaction. Good cake.